Trigonometry, an exercise on inverse trig functions. When we looked at inverse trig functions, we had that if theta naught is the principal value when we take the inverse sine, then the general solution is theta naught plus n times 360, or theta is equal to 180 minus theta naught plus n times 360, where n is any integer. If theta naught is the inverse cosine of something, where theta naught is the principal value, then the general solution, theta, is plus or minus theta naught plus n times 360 degrees, where n is an integer. And if theta naught is the inverse tangent of something, where theta naught is the principal value, then the general solution, theta, is equal to theta naught plus n times 180 degrees, where n is any integer. Now, the following is an exercise. Pause the video at this point and have a go at the questions. When you've finished, restart the video and I'll go through the answers. Okay, let's have a go at them. Now in question 1, we're asked to find the inverse tangent of 1.23 in the range 0 degrees to 360 degrees. Now to do this, we find the inverse tangent of 1.23 using a calculator, and that gives us an answer of 50.9 degrees when rounded off to one decimal place. And this is our principal value. So the general solution is the principal value plus n times 180 degrees. So if we let n equal 0, that gives us 50.9 plus 0 times 180, which is 50.9 degrees, and that's in the range we want. If we took n as minus 1, we'd get minus 129.1 degrees, which is not in the range, it's below 0. If we took n is 1, we get 50.9 plus 1 times 180, which is 230.9 degrees, which is between 0 and 360, and so that is a possible solution. If we take n is 2, we get 50.9 plus 2 times 180, which is 410.9 degrees, which is too large. So the possible solutions are 50.9 degrees and 230.9 degrees. In question 1b, we're asked to find the inverse sine of 0.35, where the angle has to lie between 0 and 360 degrees. Well, we start by looking up 0.35 on the calculator, and that gives us 20.5 degrees when rounded to one decimal place, and that's our principal value. Now we need also to know 180 minus 20.5 degrees, which is 159.5 degrees. And then the general solution is 20.5 degrees plus n times 360 degrees, or 159.5 degrees plus n times 360 degrees. So if n is 0, we get two solutions, 20.5 degrees and 159.5 degrees, and both of those lie within the appropriate range. However, if we let n equal minus 1, then the largest angle we have is 159.5 minus 360 degrees, which is minus 200.5 degrees, which is too low, it's below 0. And if we take n is plus 1, we have the smallest angle is 20.5 plus 360 degrees, which is 380.5 degrees, which is too large. And so the possible solutions are 20.5 degrees and 159.5 degrees. In part C, we're asked to find the inverse cosine of 0.28. Now, if we do that on the calculator, we get 73.7 degrees to one decimal place, and that's our principal value. Now, for the inverse cosine, the general solution is the principal value plus n times 360 degrees, or minus the principal value plus n times 360 degrees. Now, if we let n equal 0, then minus 73.7 degrees plus 0 times 360 is minus 73.7, which is below 0, so we don't want that solution. If we take the positive value, 73.7 plus 0 times 360, we get 73.7, which is in the region we want. If we take n is 1, then minus 73.7 plus 1 times 360 is 286.3 degrees, which is in the region we want, and so it's a suitable solution. Now, if we take the positive value, 73.7 plus 1 times 360, that gives us 433.7 degrees, which is too large, and in fact all other cases are too large. And so the two possible values we have are 73.7 degrees and 286.3 degrees. In part D, we want the inverse sine of minus 0.4. Well, on the calculator we get minus 23.6 degrees, and that's our principal value. Now with the inverse sine, we want the principal value and we want 180 minus the principal value. Well, 180 minus 23.6 is 203.6 degrees. So the general solution is the principal value plus n times 360 degrees, or our other value plus n times 360 degrees. So we have minus 23.6 degrees plus 0 times 360 is minus 23.6, which is below 0 and so not in the region. 203.6 plus 0 times 360 is 203.6, which is in the region we want. If we have minus 23.6 plus 1 times 360, we get 336.4 degrees, which is in the region we want. And if we take 203.6 plus 1 times 360, that's 563.6, which is too large. So the suitable solutions that we can have are 203.6 degrees and 336.4 degrees. In question 2, we're asked to find the angle in the range 180 to 540 degrees. Now in 2 part A, we're asked to find the inverse cosine of 0.6. And if we do that on the calculator, it's 53.1 degrees, and that's the principal value. Now the general solution is the principal value, or minus the principal value, plus n times 360 degrees. So if we consider the case when n is 0, we can have 53.1 degrees plus 0 times 360, which is 53.1 degrees, which is too small, it's below 180. If we take n is 1, we can have minus 53.1 plus 1 times 360, which is 306.9 degrees, which is in the right region. If we take 53.1 plus 1 times 360 degrees, that's 413.1, which is also in the right region. However, if we let n equal 2, we end up with minus 53.1 plus 2 times 360, which is 666.9 degrees, which is too large. And any further ones will also be too large. And so we have two possible solutions, 306.9 degrees and 413.1 degrees. Now in part B, we're asked to find the inverse tangent of minus 0.85. And if we do that on a calculator, we get minus 40.4 degrees. So that's our principal value. Now, for the inverse tangent, the general solution is the principal value plus n times 180 degrees. So, if we take n as 1, that gives us minus 40.4 plus 1 times 180, which is 139.6, which is below 180, and therefore not in the region we want. If we take n is 2, then we have minus 40.4 plus 2 times 180 degrees, which is 319.6 degrees, which is in the region we want. And if we take n is 3, we end up with minus 40.4 plus 3 times 180, which is 499.6 degrees, and again that's in the region we want. And if we take n is 4, we end up with minus 40.4 plus 4 times 180, which is 679.6 degrees, which is above 540 and therefore not in the region we want. And so we're left with two possible solutions, 319.6 degrees and 499.6 degrees. In part C, we want the inverse sine of 0.45. Well, that comes out to be on the calculator 26.7 degrees, and that's our principal value. Now we also need 180 minus 26.7 degrees, which is 153.3 degrees. Now the general solution is one of those two plus n times 360 degrees. So if we take n is 0, the larger one, 153.3 degrees, plus 0 times 360 degrees is 153.3 degrees, which is too small. It's below 180. If we take n is 1, 26.7 degrees plus 1 times 360 is 386.7 degrees, which is in the region we want. And the other one, 153.3 plus 1 times 360, is 513.3 degrees, which is also in the region we want. It's below 540 degrees. However, if we take n is 2, we end up with 26.7 degrees plus 2 times 360, which is 746.7 degrees, which is too large, and from then on all the rest are too large. So we have two possible solutions, 386.7 degrees and 513.3 degrees. Now in part D we want the inverse sine of minus 0.45, which when we do it on a calculator gives us minus 26.7 degrees. And that's the principal value. Now we also want the other value, 180 degrees minus the principal value, which is 180 take away minus 26.7 degrees, which is 206.7 degrees. So if we let n equals 0, we have minus 26.7 degrees plus 0 times 360, which is minus 26.7 degrees, which is too small. We also have 206.7 degrees plus 0 times 360, which is 206.7 degrees, which falls in the correct region. If we take n is 1, we have minus 26.7 degrees plus 1 times 360, which is 333.3 degrees, which is in the region, and 206.7 plus 1 times 360 degrees, which is 566.7 degrees, which is more than 540 degrees, and therefore not in the region we want. So we have two possible answers. They are 206.7 degrees and 333.3 degrees. In question 3 we have the same type of problem, but this time we'll use a different method to solve them. We use the acronym ACTS. This tells us where in a diagram the sine, cosine or tangent are positive or negative. Then from the diagram we can read off the appropriate angles. We'll also draw graphs to check whether we're getting the right answers. In question 3 we're asked to find the angle between minus 180 degrees and 180 degrees. And in part A we're asked to find the inverse sine of minus 0.2. Now the first thing we do, on the calculator we work out the inverse sine of plus 0.2, which is 11.5 degrees when rounded to one decimal place. We then draw some x and y axes, and we draw two diagonal lines going through the origin. We then label the angles between the diagonal lines and the x-axis as 11.5 degrees. And then, going clockwise around, we label each quadrant A, C, T, S, ACTS. Now the original equation was the inverse sine of minus 0.2, so we want the quadrants where sine is negative. Now sine is positive in A because all are positive, and in S because sine is positive. So we want the quadrants labelled C and T. And we want the angles between minus 180 and plus 180 in those two quadrants. Now if we go around clockwise to T, that's in the negative direction, then the angle is minus 180 degrees take away 11.5 degrees. That is minus 168.5 degrees. And if we go to C clockwise, that's minus 11.5 degrees. If we go to T or to C anti-clockwise in the positive direction, it'll be an angle greater than 180 and therefore not in the region we want. So we have two possible answers, minus 11.5 or minus 168.5. Now we can see this if we draw a diagram. If we draw the sine curve and then draw a line across at y equals minus 0.2, we see it crosses the graph at 2 points. One is at minus 168.5 degrees and the other is at minus 11.5 degrees. And so the graph shows that we were correct when we did it the first time. In part B, we're asked to find the inverse tangent of minus 2.5. Well, to start with, we find the inverse tangent of plus 2.5, and using the calculator we get 68.2 degrees, rounded off to one decimal place. So we draw x and y axes and then two diagonal lines at 68.2 degrees to the x-axis. We label all the angles between the diagonal lines and the x-axis as 68.2 degrees. We then label the quadrants A, C, T and S acts. Now we were asked for the inverse tangent of minus 2.5. So we want the tangent to be negative. Now it's positive in A because they're all positive there, and it's positive in T. So it's negative in S and C. So if we go anti-clockwise from the x-axis around to the diagonal line at S, that's an angle of 180 minus 68.2 degrees, which is 111.8 degrees. If we go clockwise from the x-axis to the diagonal at C, that gives us an angle of minus 68.2 degrees. So theta can take two values, that's 111.8 degrees or minus 68.2 degrees. Now we can check this up by drawing a graph. If we draw the tangent graph and then a line across at y equals minus 2.5, we see that the line crosses the graph at minus 68.2 and 111.8 degrees. This confirms our original answers. Now, in question 3 part C, we're asked to find the inverse cosine of minus 0.55 in the range minus 180 degrees to 180 degrees. Now the first thing we have to do is we have to find the inverse cosine of plus 0.55. Now using a calculator we get that as 56.6 degrees when rounded off to one decimal place. We then draw x and y axes and two diagonal lines crossing over at the origin. Then between the diagonal lines and the x-axis we mark the angles as 56.6 degrees. Next we label the quadrants acts A, C, T, S going round clockwise. Now in the original question we were asked to find the inverse cosine of minus 0.55. So we need to find where is the cosine negative. Well, it's positive in A because all are positive, and in C because cosine is positive. So it's negative in the regions S and T. Now, to get to the angle in S, we have to go anti-clockwise, which is positive, 180 degrees minus 56.6 degrees, which is 123.4 degrees. And to get to the angle in T, we have to go clockwise, which is negative. So it's minus 180 take away 56.6 degrees, which is minus 123.4 degrees. And so we have two solutions, 123.4 degrees and minus 123.4 degrees. Now we can see this on a cosine graph. If we draw a horizontal line at y equals minus 0.55, then we see it crosses the curve at 2 points. They are minus 123.4 degrees and plus 123.4 degrees, and so they confirm our original answers. Now, in part 3D, we're asked to find the inverse sine of 0.6 in the range minus 180 degrees to 180 degrees. Well, the first thing we do is we use our calculator to find the value of the inverse sine of 0.6, and that comes out to be 36.9 degrees when rounded to 1 decimal place. We then draw axes and two diagonal lines. We mark the angles between the diagonal lines and the x-axis as 36.9 degrees. We then label the quadrants going clockwise acts A, C, T and S. Now, in the original question we were asked for the inverse sine of 0.6. So we want the quadrants where sine is positive. Now it's positive in quadrant A because all are positive, and it's positive in quadrant S because sine is positive. So to get to the angle in A, we have to go anti-clockwise 36.9 degrees, so theta could be 36.9 degrees. To get to S, we have to go anti-clockwise 180 minus 36.9 degrees, and so theta could be 143.1 degrees. So we have two possible solutions, 36.9 degrees or 143.1 degrees. Now we can see this if we draw a sine graph. If we draw a horizontal line across where y is 0.6, we see it crosses the curve at 2 points, 36.9 degrees and 143.1 degrees. And that confirms our original answers.